Hi everyone. Welcome to our tutorial on C++ programming. Today, we are going to dive into some fundamental concepts, constants, variables, data types, and keywords in C++. Let's get started. First, let's talk about constants. A constant is exactly what it sounds like, something that doesn't change. In programming, we use constants to represent fixed values. For example, if you think of the number 44, that's an integer constant. Similarly, numbers like 12.23 or 34.53, which have decimal points, are floating point constants. Then, we have character constants, like the letter A or Z, which are always enclosed in single quotes. And finally, there are string constants, which are sequences of characters like C++ or a programming, and these are enclosed in double quotes. Now, on to variables. Imagine you are writing a letter and you want to refer to your friend by their nickname instead of their full name each time. Variables work similarly in programming. They're names that we assign to specific memory locations in our computer, making it easier to access and manage the data stored there. For instance, if we store a number in a memory location and name it X, we can easily use X in our program to refer to that value without needing to know the actual memory address. But how does this work in computer memory? Let's delve deeper. Computer memory can be thought of as a massive grid of tiny storage units called bits. Each bit can hold either a 0 or a 1, representing the most fundamental level of data in a computer. These bits are grouped together in sets of 8 to form bytes, which are the basic units of storage in computer memory. Each byte in memory has a unique address, much like how every house on a street has a unique address. This address allows the computer to locate and manage the data stored in memory. When we declare a variable in our program, the compiler, which is the tool that translates our code into machine language, allocates a certain number of bytes in memory to store the variable's value. For example, if we declare an integer variable with int x is equal to 10, the compiler typically allocates 4 bytes of memory to store this integer, though this can vary depending on the system and compiler. Next, the computer stores the number 10 in these 4 bytes. In the computer's language, the number 10 is represented in binary as 1, 0, 1, 0. These bits are placed into the reserved memory locations. The exact way the binary digits are stored can vary due to something called endianness, but that's a more advanced topic. Then, instead of having to remember the exact memory addresses where the number 10 is stored, you simply use the variable name x. This is like using a nickname instead of a full name. It makes things much simpler and easier to manage. This abstraction means you can write and read your code without worrying about the specific memory addresses. The compiler and operating system handle the memory management behind the scenes, ensuring that your data is stored and retrieved efficiently. This process includes various techniques to optimize performance and manage resources effectively. By using variable names, you can focus on the logic of your program, making it more readable and maintainable, while the computer takes care of the details of memory storage. In C++, data types are crucial because they determine the kind of data a variable can hold, the size of memory allocated for it, and the operations you can perform on it. First, let's dive into the various fundamental data types. Starting with integers, you have the int type, which is typically used for whole numbers and usually occupies 4 bytes of memory. For smaller ranges, you might use short, which is generally 2 bytes, or long, which is at least 4 bytes but can be larger depending on the system. If you need to handle very large numbers, long is the way to go, typically taking up 8 bytes. When dealing with numbers that have decimal points, C++ offers floating point types. The float type is used for single precision floating point numbers and usually takes up 4 bytes. If you need more precision, double is a better choice, often occupying 8 bytes. For even greater precision, there's long double, though the size can vary. It often provides more precision than double. Characters are handled by the char type, which is used to store single characters and usually takes up 1 byte. For text and strings, you typically use arrays of char or the std string class from the standard library. Booleans in C++ are represented by the bool type, which can hold either true or false. This is very useful for controlling logic flow with conditions and loops. In C++, the void data type is used to indicate that a function does not return any value. It is also used for pointers that can point to any type of data, though you need to cast them to a specific type before using them. Essentially, void signifies nothing or no type. In C++, user-defined data types allow you to create custom data structures tailored to specific needs. Examples include structures, struct, which group different types of data under a single name, classes, which extend structures with methods and access control for object-oriented programming, unions, which enable different data types to share the same memory space, and enumerations, enum, which define named integer constants for better code readability. Additionally, derived data types, such as arrays, let you store collections of data, while pointers and references provide advanced memory manipulation techniques. I'll explain these user-defined and derived data types in more detail in my future videos. Now, let's discuss keywords. Keywords are reserved words in C++ that have special meanings to the compiler. They are like the grammar rules of our programming language. For instance, int is a keyword used to declare integer variables, float is for floating point variables, char is for characters, and bool is for Boolean values. We also have control statement keywords like if, for, while, and switch that help us control the flow of our programs. It's important to remember that we can't use these keywords as names for our variables because their meanings are already defined in the language. Now, let's summarize what we've covered. Constants are values that remain unchanged throughout the program. They can be integers, floating point numbers, characters, or strings. Variables are names assigned to memory locations to make it easier to access and manage data. In computer memory, variables are stored as bits grouped into bytes, each with a unique address. We use variable names to refer to these memory locations, making our code more readable and manageable. Data types specify the kind of data a variable can hold, like integers, characters, floating point numbers, booleans, and void. Keywords are reserved words with predefined meanings in C++ that we cannot use as variable names. So, I hope this gives you a clear understanding of constants, variables, data types, and keywords in C++. I hope this tutorial has been useful. If you enjoyed this video and want to see more tutorials like this, please hit that subscribe button and click the bell icon so you never miss an update. Don't forget to like this video if you found it useful, and share it with your friends who are also learning C++. Your support really helps me keep creating more content for you all. Thanks for watching, and happy coding!